So let's start the class. Right, I guess it's audible. Okay. Yes guys, so good afternoon. So I guess hope you are doing well, and the thing is we are back with IPE classes for both class 11th and class 12th, right. So IPE exam is going to be start from Feb end right now, so for both Telangana and Andhra Pradesh students. So in this series we are going to concentrate about the physics, that is class 11th and class 12th. So the thing is, one day we'll revise, one day we'll start with class 11th and next day will class 12th, okay. And when we start doing for class 11th, the next day should be the preparation, like whatever we have discussed should be done, right. So there is no carry forward of that question for the next days. So if you are starting class 12 today, so whatever question we are discussing, that should be completed in the next day, should be revised everything, okay. We should not carry forward that also. So in this particular session we are going to start with class 12th IPE. In last session we were started class 11th, that is work, energy and power, and we were seeing, we were seeing that this work, energy, power long answer questions, no, yes. And today the topic is waves. So before that let me introduce one thing. So IPE classes are started now, so we are intaking both offline and online batches. So if you are willing to register, so try to contact the number which is scrolling down or will be given in the description boxes, so that you can able to join the classes as early as possible, okay. So if you are not started also, no issues, we will help you to reach 60 out of 60 in physics, right, okay. So let's wait for 1 or 2 minutes and the people are joining over here, okay. So let's discuss first what is the blueprint of the class 12th, right. And we were discussing that class 12th exam is going to start at Feb 26, right. And when you see that physics exam, it is, yeah, it is March 13th, 10th and 13th. So for Telangana it is 10th and for Andhra it is 13th. For Andhra the exam is going to start from 24th, right, okay. 10th and 13th, you can mark the dates, okay. Let's discuss the blueprint of this, okay. Fine. So when we are talking about the mark distribution, it has been distributed into 8 marks, 4 marks and 2 marks, right. So 8 marks usually called as long answer questions, LAQ. When we talk about the 4 marks, it is short answer question, SAQs. When we talk about the 2 mark question, it is very short answer question, VSAQs, okay. So here is the chapters which we are going to concentrate on this series, okay. So the chapters are waves, ray optics, wave optics, electric charges and fields, electrostatic potential, current electricity, moving charges and magnetism, magnetism and matter, electromagnetic induction, AC, that is alternating current, electromagnetic waves, dual nature of radiation, atoms, nuclei, semiconductor electronics and communication system, okay. So these are the chapters which we are going to concentrate, and each chapter will be having different types of questions, right. Now when we talk about waves, we will be concentrating on 8 marks, that is LAQ, long answer questions. Okay, from waves we will get total of 8 marks. When we talk about ray optics, so one SAQ will be there, one VSAQ will be there. So total of 6 marks. Okay. When we talk about a wave optics, one SAQ will be there, right? So total of 4 marks. Electric charges and fields, one SAQ, right? And electrostatic potential, one SAQ. So this is 4 and 4. Current electricity, again one 8 mark question will be asked. And moving charges and magnetism, one 2 mark question and one 4 mark question, that is one VSAQ, one SAQ, right? When we talk about magnetism and matter, 2 plus 2, like 2 questions from VSAQ, okay, that is 4 marks. And electromagnetic induction, one 4 mark will be there, alternating current, one 2 marks, and electromagnetic wave, 2 marks, and the dual nature of radiation, 2 plus 2, that is 4 marks. That is 2 plus 2 in the sense very short answer questions, okay. Atom 4 and nuclei again 8 marks. So when we talk about long answer question, 16 marks will be covered right now out of 3 questions. So like 3 questions they will be asking, out of 3 we should write 2 questions, right. So nuclei and then current electricity and then wave. If you concentrate on these lessons, we can answer easily, we can get 16 out of 16 right now. Next, semiconductor and electronics, no, 2 plus 4, like one VSAQ, one SAQ will be there. Then communication system, one VSAQ. So total of 60 marks will be there, right. So when we talk about a total of 60 marks, 2 8 mark question will be there, that is 16 marks, right. 10 very short answer question, that is 20 marks, right. No, so remaining 24 marks from, yes, SAQ. VSAQ is 10 questions, SAQ is 6 question we should write, yes, no, and then yes, long answer question is 2. Okay, understood. So this is the lessons which we are going to concentrate. Okay, if you want you can take a note of this. Done? Yes, once it's completed we can go into the lesson. Yes, we are going to start with long answer questions. Long answer, then short answer we'll see, and then very short answer. So what are the things which we are going to see is in this particular series? Let me give a brief note about that, okay. So we will see long answer questions, short answer questions, very short answer questions. This is the sequence which we are going to see, okay. First one, second one, third one, like we will be covering every lessons, okay. Then we will see 5 to 6 model papers. We'll solve 5 to 6 model papers, and students who are present in offline classes will be having 3 examinations, okay. You can write the examination, we will discuss the paper, again you can take time of 2 days, again write the examination, discuss the paper, 2 days time, again paper, okay. So like this we will discuss, okay. So this is the one of the thing we can do once we complete the classes of this LAQ, SAQ and VSAQ, right. So when we are able to write this many times exam now, we will be clear that like our mind will be clear that like we can go and give exam, yes we can get 60 out of 60, that is the aim, right. No, we need to get 60 out of 60, that's the thing we should aim for the physics, okay. Yes, we can get easily if you concentrate and if you follow the class properly, if you take the notes, if you write the notes properly, and if you revise that notes regularly to not carry forward, yes, obviously you will get it 60 out of 60, okay, fine. So now we will go into the topic. So which topic we are going to see is waves, okay, the topic is waves. Fine. So I guess it's visible. Okay. So the first question which we are going to talk is, explain the formation of stationary wave in stretched string and hence deduce the law of transverse wave in stretched strings. Okay. So what are the things they have asked from the question? We need to understand, we need to decode it. What are the things, how many subtopics are there in the questions? Yesterday we have talked about for the IPE of 11th class people, okay, that work energy power we were talking. So what are the things they were asking? Like first the thing they were asking, what is work, what is kinetic energy, and deduce the work energy theorem. Like step by step we need to calculate it, right? No, similarly, okay, I guess you have written the exam of class 11th, right? So you will be having some ideas about that, how the question will be asked, how we need to answer that question, right? So the class 11th people having the experience first time, they are going to experience first time, but class 12th, no, you have already experienced the center examinations, how will be the center and what type of questions will be asked and how we need to prepare accordingly, everything, right? Okay. So explain the formation of stationary wave. So formation of stationary wave in stretched strings and hence deduce law of transverse wave. Okay, this is the two things they are asking in the question. So stationary wave means when two progressive wave of same amplitude and frequency traveling along the same straight line in opposite direction. So what is the meaning of that? Two progressive wave of same amplitude. Amplitude means A will be same, A1 and A2 will be same, which is equals to A. Okay, A is not called as amplitude, we will say, right? So and frequency traveling along the same straight line but in opposite direction. One is coming like this, another one is coming like this. Okay, so both are in the same straight line but in opposite direction. Okay, but in opposite direction, right? Superimpose, a stationary wave is formed. Superimpose in the sense when they coming in the same direction but same straight line opposite direction, they will mingle, okay, they will superimpose and a stationary wave is formed. Got it? Got the point? Two progressive wave, okay, two progressive wave of the same amplitude. First point, two progressive wave of the same amplitude and frequency traveling along the same straight line in opposite direction. Okay, clearly understand the point? Okay, same amplitude, same frequency going in a straight line, same straight line in opposite direction forms a stationary wave. Okay, first point is clear, right? Okay, so now formation of stationary wave. So how it has been formed? We have got to know what is the meaning of stationary wave, right? No? Now how the formation has been taken place. A string is fixed between two rigid support. So suppose this is my string fixed between two rigid support. Okay, two rigid in the sense it has been fixed, no, the support has been fixed. Okay, it is excited perpendicular to its length to generate transverse wave. Excited perpendicular. Okay, generate transverse wave which travel in opposite direction from the point of excitation. Okay, so this is the formation of stationary wave. So once again we will see a string is fixed between two rigid support. It is excited perpendicular to its length to generate transverse wave which travels in opposite direction from the point of excitation. Say from the point of excitation. Okay, yeah. So these transverse wave get reflected at rigid support and overlap on each other. So what happens here? Wait a minute, let me take that. Yeah. So what happens here is, when I talk about the rigid support, no, when I start disturbing here and disturbing here, they will travel like this. From this point the particle will travel in this direction, from here the particle will travel in this direction, right now. So that is the thing, that these transverse wave get reflected at the rigid support and overlap on each other, produced stationary wave. Stationary wave means they overlap, the waves are travelling in straight line but in opposite direction and overlap to form a stationary wave, right now. Due to the superposition of wave, the amplitude of wave is modified to form nodes and antinodes. So what happens? Superposition of waves and amplitude of waves is modified to form nodes and antinodes. The amplitude of a resultant wave depends on the phase. Okay, so this is the third point which we need to note it down. Okay, yes, you can take a point of this. Done? Yes, can we go for the next one? Okay. So now we will write the equation. So first what we will do, y1 will be equals to a sine of kx minus omega t, 1 will be in opposite direction. So what we should do, y2 will be equals to a sine of kx plus omega t. Okay. So one is y1 a sine of kx minus omega t, one is a sine of kx plus omega t. Now be displaced of a particle of a string due to incident and reflected wave. So one is going and one is reflecting back. So these are the two equations which we need to note it down. Now what is the superposition, like they are collided together, no? So according to principle of superposition, the resultant of displacement y will be equals to y1 plus y2, right now, y will be equals to y1 plus y2. So what we will do, we will add both the things, a sine of kx minus omega t, a sine of kx plus omega t, right. So a we can take commonly outside, sine of kx plus kx minus omega t, sine of kx plus omega t, right. This is a minus b, a plus b, no, looking like that, no, a minus b and a plus b. See here, yeah. So when I talk about kx, let me take this as a, omega t as b. So when I talk about this equation, I can say this as y equals to a time of, say a of sine of a minus b plus sine of a plus b. Is this looking like that, no? Kx minus omega t, kx plus omega t. So what we can do, from the identity, sine of a minus b, a plus b will be equals to 2 sine a cos b. So 2 sine a cos b, in the sense this one we have considered as a, this one as b. So 2a sine kx cos omega t, okay, 2a sine kx cos omega t. So the resultant displacement will be periodic in space with amplitude. So we have talked about amplitude, right. So here amplitude will be 2a sine kx, 2a sine kx. So a cos omega t, right now. After superposition, what happens? So we have got the equation y is equals to 2a sine kx cos omega t. So from this 2a sine kx, no, is called as amplitude. Okay. Now at the position if kx is equals to 0, kx is equals to 0, like sin kx will be equals to 0, nodes are formed. If position where sin kx is equals to 1 antinodes are formed. Antinodes are formed. So antinodes in the sense like if it's sin 0, no 0, so total term will become 0. Now what about 1 if I substitute? Yes, 2a cos omega t we will get. Okay, so y will be equals to 0 when we substitute, kx will be equals to 0. So kx equals to 1, y will be equals to 2a that is a cos omega t, that's it. Got it? So nodes, antinodes. When it forms, x is equals to 0, kx is equals to 0, kx is equals to 1, right? Can we go for the next one? Note it down. Okay, done. So the next one is so x is equals to 0 if we substitute, kx is equals to 0 if we substitute. So nodes are formed, 0, lambda by 2, lambda, 3 lambda by 2, it goes on. Okay, so 2 lambda, like that it will go 2 lambda, then 5 lambda by 2, then 3 lambda. Okay, let me write that. Okay, yeah. So when I talk about the nodes, no, it is 0 comma 1 comma, so 1 by 2 comma 1 comma 3 by 2 comma 2 comma 5 by 2 comma 3, like that. So plus 1 by 2 plus 1 by 2 plus 1 by 2, it keeps on adding, right? No, so lambda, this is 2 lambda, 5 by 2, 5 lambda by 2, 3 lambda, then what will come, 7 lambda by 2, 4 lambda, it goes on up to n. Okay. Next, if we see the antinodes, lambda by 4, 3 lambda by 4, 5 lambda by 4, there is 1 by 4 is common, so odd numbers, so 3 by 4, 5 by 4, 7 by 4, 9 by 4, so lambdas. Okay, so this is for a node and this is for antinodes, and this is the diagrams. Okay, when L is equals to lambda by 2, L is equals to lambda, L is equals to lambda 3 lambda by 2. Okay, yeah, you can take a note of this. Done? Okay. Now we have completed the first part of the equation, that is stationary wave is wave in stretched string and hence deduce the law of transverse. So we need to see the law of transverse wave, that's the thing remaining right now. So law of transverse vibration in string, that is stretched string. So let a string of a length L be stretched between the two rigid support. So when I take the rigid support, that is P and Q, let me draw the diagram over here. So this is my rigid support, so P and this is Q. So I am taking the string of length L. So this is my string of length L. Okay. When the string is plugged, a transverse wave travels along its length and get reflected from the from the ends, right? Right? So if the string vibrates in fundamental modes such that two successive notes are formed, right? No, what happens here? The particle will travel like this. Here also the particle will travel like this. No? Yes. So PQ will be equals to lambda by 2 will be equals to L, right? No? L. So what lambda? Lambda is nothing but wavelength. So 2L. So 2L. And when we talk about velocity of propagation, wave propagation, V is equals to T by mu. What is V? It is velocity. What is T? Time period. And what is mu? Is mass per unit length. Mass per unit length. Okay? Yes. So the next is velocity of propagation we have discussed, and frequency. N is equals to V by lambda. What is V? We have discussed it is root over T by mu. So when we are writing, this is 1 by 2L. Lambda is nothing but 2L and root over T by mu. So this is my frequency. So when I talk about the last, no, first law. So fundamental frequency of vibrating string is inversely proportional. So frequency is inversely proportional to the length of a string. Okay, that is first law. Second law, what it's saying? So fundamental frequency is directly proportional to square root of tension. Okay, square root of tension, and fundamental frequency is inversely proportional to, yes. So from this only, yeah, this is not time period, this is tension, sorry, yeah. So this is tension. So from this law we can say that N is inversely proportional to L, and N is directly proportional to square root of T, and N is inversely proportional to square root of mu. These are the three laws, right? Now law 1, law 2 and law 3, right? Yes, up to this we need to explain for the first question. Right now, yeah, you can take a note of this. Yes. So no need to worry about that, like if we have 5 questions, no need to complete every 5 questions in a single day, like we will keep on solving. Okay, yes, we need to solve properly, not how much questions we have done, not the quantity, the quality we should build, right? Okay. Yes, once it completed, no, we can go for the next question. Done? Okay, we'll go for the next question. So what is the next question? Explain the formation of stationary wave in an air column enclosed in open pipe. Derive the equation for the frequency of harmonic produced. Okay, so what are the things I have asked in the question? So we need to explain the stationary wave, formation of stationary wave. Okay, in an air column which is enclosed in open pipe. Now what second part is, derive the equation of frequency of the harmonic produced. Okay, these are the questions they have asked. Yes, So once you have done with the question, now we will go for the answer part, right? Okay. So harmonics, the frequency which are integral multiple of fundamental frequency, the frequency which are integral multiple of fundamental frequency is called harmonics. Okay, the first point completed. Next point, what is overtones? That's the thing we need to discuss now. Yes, overtones. What is the meaning of overtones? Yes, the frequency higher than the fundamental frequency are known as, the frequencies are which is higher than the fundamental frequency are called as overtones. Okay, an organ pipe is cylindrical tube. Okay, we will draw that. Okay, organ pipe is cylindrical tube. So when we talk about this organ pipe which is a cylindrical tube, okay, having an air column, if both end of the tube are open, it's known as, like this, both ends are open is called as open pipe. Okay, when a sound wave is sent through the pipe, it get reflected at the both end. This incident and reflected wave superimposed to form a longitudinal stationary waves. Like this they will form, no? Yes. Okay, they will go like this, they will travel like this. Okay, at the open end, the particle of an air are free to vibrate. Always an antinodes will say. Right. At each end, the waves will be phase and the displacement is maximum. Will be in a phase and displacement is maximum. Okay, these are the 4 points which we need to note it down before starting the problems, right? Yes. So this first point is frequency is higher than the fundamental frequency is called as overtones, right? An organ pipe is cylindrical tube having an air column. If both ends of the tube are open, it is called as open pipe. When a sound wave is sent through the pipe, it gets reflected at the both ends. Yes, this incident and reflected wave superimposed to form a longitudinal stationary wave. Okay, now in the previous question what we have discussed, so we were discussing about two rigid support and a particles has been traveling like this when they are superimposed. Yes, stationary wave. Here also same thing. Okay, but we have taken an open pipe. Okay, at each end the wave will be in a phase and displacement is maximum. Okay, fine, right. So harmonic in open pipes. So first harmonic. Yes, so first harmonic is fundamental frequencies we will say. Second harmonic, first overtone. Third harmonic, second overtone. Okay, so length of an air column will be equal to half of the length of wavelength, right? So L will be equal to L by 2. This is the condition we were seen, no? We were discussing. So length will be equals to lambda by 2. So lambda will be equals to 2L. This condition we were discussing in the previous slide. So first harmonic they have given, no? So N1 will be equals to V by 2L. N1 will be equals to V by 2L. Okay. Next, second harmonic. So first overtone, no? So L will be equals to L will be equals to lambda. Okay. So what will come here? N2 will be equals to V by L. Okay. So third harmonic is 3 notes and 4 antinodes. When you talk about this one, 2 notes and 3 antinodes, and length here is equals to length of a wavelength. Okay. Yes. Okay. So fine. So L will be equals to 3 lambda by 2. So lambda will be 2L by 3. So when we substitute here 2L by 3, the 3 will go upside. So 3V by 2L. Okay. So these are the diagrams for the open pipes. Okay, 1 by 2 waves and 1 waves and 3 by 2 waves, right. So conclusion, when we talk about the conclusion, no, so for open pipes the ratios will be 1:2, 2:3, 3:4, it goes on up to n, right. So this is the conclusion of the open pipe. Yes, you can take a note of this. So next question will be closed pipe. Okay, open pipe we have done. What about the closed pipe? Will be similar only, the same concept only we will discuss. Okay, so the next question is, how are the stationary waves formed in enclosed pipe? Explain the various mode of vibration in closed pipe and establish the relation between their frequencies. Okay, so first thing, the 4 points we need to discuss. What are the 4 points? An organ pipe is cylindrical tube having an air column. Okay, if one end is closed and other end is open, it's known as closed organ pipe, we will say. Okay, one end has been closed, other end is open. Okay, it's a closed organ pipe. Second point, when a compressional wave, that is sound wave, is sent through an organ pipe, the wave gets reflected at one end of the pipe. Okay, wave get reflected through one end of the pipe. So this incident and reflected waves, yes, this incident and reflected waves. Yeah, so this is my cylinder and this end is closed, this end is open. Okay, yeah, this incident and reflected wave which are formed, so which are same frequency traveling in opposite direction are superimposed along the length of the pipe and form a longitudinal stationary wave, right. Yes, so third one is at the open end where particles are medium to free to vibrate and always an antinode is formed. When there is an open, no, that's the thing we have discussed, antinode will be formed, right. Okay, here two waves will be in a phase and particle will be a maximum displacement, right. So when the reflection takes place at closed end, the two waves will be opposite phase and hence superimposition of waves gives zero displacement. Okay, superimposition of the waves, what will happen? A zero displacement will be given. Okay, so therefore always node is formed at the closed end. So open end is antinode, closed end is nodes. Okay, so coming to the first harmonic or fundamental frequency. Okay, so first of harmonic or enclosed pipe have nodes at the closed end and antinodes at the open end, right. So length will be lambda by 4, so lambda will be like wavelength will be 4 times of the length. Okay, 4 times of the length. So n will be equals to v by lambda. So what is lambda? It is 4l. So v by 4l. So similarly, when I talk about third or first overtone, third harmonic or first overtone. Okay, so l will be 3 lambda by 4. So where lambda is 4l by 3. If we substitute the values, n3 will be equals to n3 will be equals to 3v by 4l. Okay, which is 3 times of, yes, which is 3 times of, wait a minute, 3 times of fundamental frequency, right. If you see here v by 4l, here it is 3 times of v by 4l, so 3n1. So next is fifth harmonic, first, third, fifth. Okay, first, third and fifth. Similarly, the next overtone is enclosed pipe is only fifth harmonic. So what is the value? 5 by 4 of length wavelength. Okay. So L is equals to 5 by 4 into lambda, where lambda is 4L by 5. Okay. So when we substitute, N5 will be 5 times of N1. So what will be the ratios here? 1:3:5. 1:3:5. So we have drawn the diagram now. So similar only, like 1 by 4 wave, 3 by 4th wave and 5 by 4th wave. Right. So this is the conclusion of the third question. So 1:3:5, there 1:2:3:2, it goes on. Okay. Yeah, you can take a note of this. Yes. So yes, we'll stop up to the third question. We will see the remaining 2 questions in the upcoming classes. Okay. So you need to revise these 3 questions and practice these 3 questions before coming to the next class. Okay. So thank you guys. We'll meet in the next class. Bye bye.